Today we are going to cover section 11.2, Law of Cosines. So be sure to write down your essential question. How do you use trigonometry to solve and find areas of oblique triangles? So we are going to solve triangles and we're also going to find the area of oblique triangles. Now remember, an oblique triangle is a triangle that is not a right triangle. So take time to write your title, your essential question, and set up your notes. And we'll start once you're ready. Go and pause it. Excellent. So in the same manner that we prove the law of sines, we're going to prove the law of cosines. We have a triangle ABC. We have side A is opposite side the angle A, side B is opposite angle B, and side C is opposite angle C. So what we're going to do, we are going to take from point C, we are going to draw the altitude. So we're going to place a perpendicular line towards the x-axis, or towards the base in this case, in a manner that this is a right angle. So therefore that is the height, that is the altitude. And we are going to concentrate on this triangle here. Now, to prove the law of cosines, we are going to place point A as your origin. So we're going to build a y and x-axis. So I'm going to place my point A will become your origin. And side C will become your x-axis. So this is your y and this is your x. So therefore, point C is going to be located at a specific location, and it's going to be x comma y. So therefore, from this will be your x and that will be your y. And now, using angle A, we need to look for your x, and we're going to use your hypotenuse. So therefore, your x is your adjacent, and your b is your hypotenuse. Side b is your hypotenuse. So therefore, we're going to use sine, cosine, or tangent. Cosine. So it'll be the cosine of angle A is equal to adjacent over hypotenuse, so be x over b. And now we are going to leave the b by itself, so therefore we're going to multiply. So we're going to leave the x by itself. We're going to solve for x, so we're going to multiply both sides by b. The b's cancel, so therefore it gives us x equals b cosine of a. And we're going to do the same thing, but now we are going to continue using y. So we're going to continue using angle A, but we're going to use y and b. So that'll be opposite over hypotenuse, so therefore will be sine. So therefore will be the sine of A is equal to the opposite, which is y over b. We are going to leave the y by itself, so therefore we're going to multiply both sides by b. And that will give us y equals b, the sine of A. And we are going to use that because we want to be able to find the distance. We're going to use our distance formula. The distance between between C and B. So therefore, I know that A is 0, 0. I know that C will be a specific location where this is your x and that is your y, so it'll be x comma y. How about point B? What is the location of point B? So from 0, 0 all the way up to B, that is the distance C. That'll be the side C, so it'll be C. So if this is 5 units, in this case, well, 2, 4, 6, 7. If this is 7 units, this will be 7 comma 0. So in this case will be C comma 0. Now we're also going to substitute, instead of the x, we're going to replace with the value of x, which is b cosine of a. So be b cosine of a. And instead of y will be b sine of a. So now we are going to use our distance formula. Our distance formula, do you guys remember your distance formula is the square root or the difference between your x values? So it'll be x minus c, but in this case will be b cosine of a minus c. So the difference between your x values square plus the difference between your y values. So it'll be y minus 0, but in this case will be b sine of a minus 0 square. And now we are just going to simplify it. So let me square both sides. Now remember that whenever you square both sides, you might end up with an extraneous solution. But in this case, we don't have to worry about that. Now the distance is actually the distance between C and B is actually side A. So I'm going to replace this with A squared. When I multiply B cosine of A minus C squared, what will I get? Now I can multiply on the side b cosine of a minus c, b cosine of a minus c. I end up with b squared cosine of a. And also this is also square, since multiplying the b times the b, cosine times the cosine. Then I have minus, I'm going to write down c b cosine of a. Then I'm going to multiply this too. I end up with another minus cb cosine of a. And negative c times negative c will be positive c squared. I have two of them, so therefore I end up with b squared cosine square of a minus 2cb cosine of a plus c squared. And most of us will actually just do it in one step. We know that whenever we multiply it out, we end up with b squared cosine square of a. And then you multiply negative cb and negative cb, end up with negative 2. I'm going to rewrite it as bc instead, just in alphabetical order. And let me not forget my plus c squared. Now I don't need a 0 in here, so that will give me just plus b squared sine square of a. If you notice, the formula that we need to get to is this one here. And notice that I already have my c squared is here, minus 2bc cosine of a is here. So therefore, I'm going to group those two together. So let me rewrite it as a squared equals, and let me place my sine square and then my cosine square. And you probably at this point you already know the next step. And I'm gonna write down my c square first, and next my 2bc cosine of a. So notice that I have my c square, my minus 2bc cosine of a. So therefore I just need a b squared. I know that they both have a b squared, so what should I do? Correct, I should just factor it out. So we have a squared equals, factor b squared out, so I end up with c squared of a plus cosine square of a plus c squared minus 2bc cosine of a. And we know that sine square plus cosine square will be 1. So therefore I have a squared equals b squared. I don't need the 1 plus c squared minus 2bc cosine of a. So therefore we proved the law of cosines, and that is our first equation. So now we have a squared equals b squared plus c squared minus 2bc cosine of a. So take the time to write down or go ahead and paste it, and then we'll continue. So go ahead and pause it. So you do need to be able to memorize your formulas. So notice that for the formulas, we have a squared cosine of a. Then a squared, the other two will be b squared, c squared, and b and c repeat. Many of you guys will forget the 2 on your test, so you have to make sure that you remember your 2. For b squared, we have the cosine of b. Then we have b squared will be a squared and c squared, the other 2, and a and c get repeated. C squared and the cosine of c. The other 2 will be a squared and b squared, and they get repeated once again. Now, sometimes it'll be helpful to be able to solve for cosine of a, because sometimes we'll be looking for the angle. So right here on the left-hand side, let's take the time to solve for cosine of a. Let's write down the equation. There's a little tiny space in there between the c and the cosine of a. I'm trying to leave the cosine of a by itself. So what I'm going to do, I'm going to go and move my negative 2bc cosine of a to the left and my square to the right. So therefore I have negative 2 positive now, 2bc cosine of a equals b squared plus c squared minus a squared. And I'm trying to leave that cosine of a by itself, so therefore I'm going to divide by 2bc, 2bc. That cancels, so therefore I end up with the cosine of a is equal to b squared plus c squared minus a squared over 2bc. Now can you do the same thing with the second one? Solve for cosine of b. So we have a squared, so b squared equals a squared plus c squared minus 2, ac get repeated once again, and the cosine of b. So do me a huge favor, go ahead and solve for cosine of b, see what you get, and then we can compare our answers. Go and pause it. Excellent. So I'm going to solve for cosine of b. I'm going to move this expression, this term to the left, and my b squared to the right. So I end up with 2ac cosine of b is equal to a squared plus c squared, and that becomes a negative b squared. I'm going to divide both sides by 2ac. That cancels, so therefore I have cosine of b is equal to a squared plus c squared minus b squared all over 2ac. And I can do the same thing with the third one to end up with the third, but it will be the same exact process. So you want to be able to memorize these equations, and then you should be able to derive these ones if you need to. Otherwise, you just need to be able to memorize cosine of b, my b squared is negative, acr squared, ac get repeated. Now let's go to example number 1. Go and take the time to copy it down, and then once you're ready, we can start. Go and pause it. So example number 1. Given the following, given angle A to be 75 degrees, B is 12 units, and C is 10 units, find the remaining angles and sides of the triangle, and the one side that we're missing. Now, it is essential that you guys draw a triangle. So for your homework, you do need to draw a triangle. It makes it easier because you guys are going to be visually see which law you need to use, and it helps you also memorize and visualize the process. I'm going to place angle A here, and 75 degrees, so I'm at 36, 75, I'll go over to here. Now, it's difficult to make it accurate from the very beginning because we have angle A to be 75. Then we have angle B and angle C. B is 12 and C is 10. So notice that in this case my C is much longer than my A, and that should not be the case, but that's fine at this point. Now we need to solve the triangle, so we need to find the remaining sides and the remaining side and the remaining angle. So let me go and label A, B, and C. And you want to do this on your homework as well because that's going to be very helpful to be able to just visualize whether you have a shape or just list all the sides. Visualize which law you need to use, law of sines or law of cosines. So in this case, we know that A is 75 degrees. We know that B is 12 units and C is 10 units. So for the law of sines, you need a angle and an opposite side. For the law of cosines, you need two sides and the angle in between. So you need two sides and the angle in between when you are going to use the law of cosines. So therefore, I have angle A, so therefore I need to look for side A. So let's go and find A. So be looking for side A, so we're going to start with A squared. A squared is equal to the other two sides, which will be B squared plus C squared minus 2. They get repeated BC and the cosine of A. So you must memorize this formula for your test. And now we're just going to substitute. We're looking for A squared. B is 12 squared. C is 10 squared minus 2. 12 and 10 get repeated. And the cosine of 75 degrees. Remember that you have to make sure that you place your degree symbol. And it's in here, but you can barely see it. And now the only thing that we need to do is just type it into the calculator. So make sure that your calculator is on degrees. Mine is on degrees. I have 12 square plus 10 square. And what's nice about this calculator is that you can type in everything at once, just like you see it. And so remember that you want to make sure that you write down your A square. It's not an approximation. Be 181.88. And I'm going to take the square root of my answer. So therefore, A is approximately 13.2 decimal places will be great, 49. Now sometimes, most of the time they ask you about the significant figures. So in this case, they give you no decimals, only two figures. So therefore I'll be using 13. So depending on the problem on your homework. So therefore this is 13.49. And that's an approximation. And now, because I know that I have an angle in the opposite side, now I can use the law of sines to find angle B or angle C. So I'm going to find angle B using the law of sines. Remember, for the law of sines, you need an angle in the opposite side, which we do have. And I'm looking for angle B. So therefore, the sine of B over side B, which is 12, equals the sine of the angle, which is 75, over the opposite side. I'll multiply both sides by 12. So therefore, the sine of B is equal to 12 sine of 75 degrees over 13.49. So by multiplying by 12, that cancels. Now, notice that I'm not going to type in 13.49. I still have my answer here on my calculator. So what I'm going to do, I am going to take my fraction bar, 12 sine of 75 degrees, divided by my answer. So therefore, the sine of B is approximately 0.86. And I'm going to leave that there. I'm going to take my inverse sine. Make sure that you're on degrees of my answer. So therefore, angle B is equal to 59.3, or let's do 2 decimal places, 26 degrees. Now remember that with law of sines, you can end up with two different triangles. So if in this case, if we're trying to figure out whether it's 59.26 or if it's the other triangle, if we do 180 minus 59.26, then it's 120 degrees, and there's not enough space. One angle cannot be 75 and the other one can be 120. So therefore that is the angle that we need. And now to find the last angle, angle C, we just can do 180 minus 75 minus 59.26, which will be 45.74 degrees. And now we have solved the triangle. We found those two missing angles and one missing side. So now let's go to example number 2. Go ahead and copy it down. Make sure that you use a ruler for the triangle, and then we can start once you're ready. Go ahead and pause it. So I need to be able to find the three angles of the triangle. So if I need to be able to find the three angles, one of the we know that we need to use a law of sines. So I need to be able to find angle A is with the law of cosines. And we have A, B, and C, where A is 8 feet. We have B is 19 feet, and C will be 14 feet. So if you are given three sides, you have to use the law of cosines in order to be able to find the missing angle. Now, something that's very key, you don't want to end up with extraneous solutions. Whenever you use the law of sines afterwards, you might end up with a extraneous solution, or not extraneous solution. We might end up with two triangles. So one of the things that you have to make sure is that you always start with the longer side. So I'm going to start with this side. So therefore I'm going to find angle B using my law of cosines. Because if angle B is the largest triangle, the largest angle, therefore A and C must be less than 90 degrees. And therefore I won't end up with my second triangle on the law of sines. So always find, and let's write that down on the left, always find the largest angle first. So you want to make sure that you keep that in mind, because otherwise your answers might not match on your homework, and that'll be the reason why. So let's go and find angle. So find angle B. I'm going to use my law of cosines, so I'll start with b. I'm looking for, so be the cosine of b equals. Now remember that you can use your regular formula and then solve, or you can just say cosine of b will be the other two angles, the other two sides, which will be a squared plus c squared. That's b, so therefore it will be minus b squared over 2 ac get repeated. So the cosine of b, we're looking for angle b, equals a, which is 8, b will be 19, and c will be, no, c will be 14, and b is 19, all over 2a, which is 8, and c, which is 14. So those, one of the things to keep in mind that those two will be repeated. And now we can just type in this into the calculator. So I'm going to use my fraction bar, so it'll be 8 squared plus 14 squared minus 19 squared divided by 2 times 8 times 14. And now I'm going to take, let me just change it to a decimal. And one of the reasons that you want to make sure that you cosine of b, you write it down, is because that way you have an idea if you end up with an error, so an approximation, negative 0.45. You have an idea of if it gives you an error, why. So now I'm going to take the inverse cosine of my answer. And my angle B is approximately 116.8 degrees. So notice that if we have not found B first, then your sine, when you do your law of sines, then you might end up with your second triangle as your solution. But if you find the largest angle, once we find angle A, we know it has to be less than 90 degrees, because otherwise it'll be too big for a triangle. So therefore you have a choice. Do you want to use the law of sines or the law of cosines? I'm going to use the law of sine. So now that I have a side, I can use, and let's go and find A, so it'll be the sine of A is equal to over A, which is 8, the sine of 116.8, which I still have on my calculator, or no, yeah, I do still have, over 19. I'll multiply both sides by 8, so therefore that gives me the sine of A is equal to 8 sine of 116.8 over 19. So having that in my calculator, I want to make sure that I get more of an exact answer. So I'm going to end up with 8, the sine of 116.8, and we don't want to do that, right? We want to place answer instead. Divide by 19. Otherwise, you're going to start rounding up too much and your answers are not going to match. So therefore, the sine of A is equal to 0.38. I'm going to take my inverse sine of my answer. So therefore, A is equal to 22.08 degrees. And notice that, so make sure that you guys match how many decimal places they want on your homework. But notice that if I want to be able to find my other angle, if I do 180 minus 22.7, or just my answer is 2.7, that cannot be an angle because 116 plus 157 will be greater than 180. So that's why we always want to make sure that we get the first largest angle when using the law of cosines if you're given three sides. And from there I can go and find my third angle, 180 minus 22.08 minus 116.8. That can't be the case. I miss a 0 there. So it'll be 41.12 degrees. Example number 3. Go ahead and take the time to copy it down, or you can just go and paste it from your cutouts. Once you're ready, you can start. Go and pause it. So trusses are used to support roofs on buildings. So notice that these are your trusses on your roof. So if you have a attic, you probably have trusses in there. The simplest type of roof is a triangle, as shown here. Find angle B to the nearest degree for the roof truss. And notice that they give you a nice picture. So find angle B and see what you get, and then we can compare answers afterwards. So go and pause it, try it, and then we can compare. Excellent. So in this case, we're looking for angle B. So therefore, be the cosine, and we are given 3 sides. So therefore, we are forced to use a law of cosines. The cosine of B is equal to the other 2 sides, which are a squared plus c squared minus b squared over those 2 get repeated, 2ac. And now we just need to substitute the information that will give us. The cosine of B is equal to A, which will be 11, plus C, which will be 9, minus B, which is 6 squared, over 211 times 9. Those 2 get repeated. So therefore, the cosine of B will be equals. I'm going to use my fraction bar. I'm going to convert it to a decimal, and I'm going to write that down first. You want to make sure that you give me that step and not just the angle. And now your angle is approximately, I want to take my inverse cosine of my answer. So it'll be 33.03 degrees. Now remember that with the law of cosines, you do not need to figure out whether you have 1 or 2 triangles, because of the law of cosines. They'll give you an angle on your from 0. They'll give you an angle from 0 to 180 degrees. So either on quadrant number 1 or quadrant number 2. So if it's 33 degrees, so which will be over here, the cosine is your x value. The other angle that's located, it's down over here. And your angle cannot be 327 degrees. So therefore, whenever you use cosine, you automatically will give you the correct angle every single time, since they're giving you from 0 to 180 degrees. So that will be your answer for letter B. And the last example we are going to be looking at here's area formula that comes very handy at times when you are trying to solve some challenging problems in geometry. So go and paste it or copy it down, and then example number 4, go ahead and write it down. Go ahead and pause it, and we'll start once you're ready. Excellent. So for Heron's area formula, remember that we already covered another formula before. Do you guys remember your formula whenever you are able to use your sign? Starts with 1/2. And we have 2 sides, A, B, and the sine of the other angle. So, or area is equal to 1/2 BC, that's sine of A, or 1/2 AC, sine of B. Now this ones are very helpful in the way that I actually just think about it. If you have a non-right triangle, if you have two sides and the angle in between, then you can use this formula here. So that comes very handy in some SAT questions. The other one, if you have three sides, you can also find the area. So in this case, if you have three sides, you can find the area using Heron's formula. And there's a proof on your textbook if you want to be able to find out where it comes from. It's just a little more lengthy, so we're not going to cover the proof. So first you need to be able to find S. To find S is not the average. We always, the most common mistake that people make is that they find as the average. No, we're going to add all three sides. So 43 plus 53 plus 72. We are going to divide by 2. So therefore S will be equals, and we're just going to use 84. And this comes very handy even whenever you have to have a triangular shape in your garden and you need to be able to find how much lawn you need to plant or the square footage. This comes very handy. So therefore your area is equal to the square root will be S, which is 84. And then each of the sides minus A. So it'll be 84 minus the first side, which is 43. 84 minus the second one, which is 53. And 84 minus the third one, which is 72. And we are just going to type that into the calculator. So 84 minus 43. 41. So the square root of 84 times 41. 84 minus 53 minus 31 and 84 minus 72. And you can just type it in at once if you want. So I'm just going to take the square root of 84 times 41 times 31 times 12. So the area is approximately 1131.89 meters square. So now you have three different ways that you can find the area. 1/2 base times height. You can use your sine formula to find the area, or you can use Heron's formula to find the area. So this will conclude the lesson for today. Your homework will be posted online. Have a great day, and I'll see you guys next time.